Geometry. Welcome to your last section of Chapter 6. We are going to be talking about conditions of special parallelograms again today. We're going to be more applying them today than learning about what they are and why they work. But first, as always, let's start out with a warm-up. I want you to give the most precise classification to each of these parallelograms and then justify your answer. So go ahead, pause the video, take a minute, give this a whirl, and then press play when you're done. All right, hopefully you have something like this on your paper. For our first shape, we can see that the diagonals are congruent, so that means that we have a rectangle. Since they are also perpendicular, as we see that we have this little right angle box in there, that means we have a rhombus. Since it's a rectangle and a rhombus, we have a square. For our second one, we can see that the diagonal bisects the opposite angles. Since our diagonal bisects opposite angles, that means we have a rhombus. We don't have anything else that could conclude that it's a rectangle as well, so the most precise classification that we can give is a rhombus. So let's get into using these properties of special parallelograms. We are told that our quadrilateral STUV is a rhombus, and we want to find the values of x and y. So since we have a rhombus, that means that these two angles, those are all the same measure because our diagonal TV bisects the angles T and V. So to find y, we have to set 65 minus y equal to the other side of that angle, 5y plus 5. And then to find x, we have to set 4x plus 3 equal to 5x minus 10. So, solving this out, let's subtract 5 from both sides and add y to both sides. So we have 60 is equal to 6y. Divide both sides by 6. We get 10 equals y. On our other side, to find x, let's subtract 4x from both sides and add 10 to each side. So we have 13 is equal to x. There we go. Simple enough on that one. For this one, we don't have a picture, but we are told that we have a parallelogram ABCD. AC is equal to 3w minus 1, and BD is equal to 2 times quantity w plus 6. What must be true for ABCD to be a rectangle? So let's draw this out, because I know I'm a visual person. So I know that there must be some other visual people. So if we draw this out, we have A, B, C, D. We know that AC is equal to 3w minus 1, so across here, and BD is equal to 2 times w plus 6. We know that to be a rectangle, our diagonals must be congruent. So that means they have to have the same length. So we set 3w minus 1 equal to 2 times w plus 6. Distribute the 2. 3w minus 1 is equal to 2w plus 12. Subtract the 2w, add the 1. We get w is equal to 13. All right, I'm going to have you try this one on your own, so go ahead, pause the video, read the problem, see what you get, and then when you're done, press play, and I will go through it with you. All right, so we are told that we have parallelogram ABCD, and we're given equations for all of the angles that are marked in here, 1, 2, 3, 4, and we want to find values of x and y so that we have a rhombus. Remember, we need AC to bisect opposite angles. So for bisecting, the measure of angle 1 has to be equal to the measure of angle 2, and the measure of angle 3 has to be equal to the measure of angle 4. So setting these equal to each other, we have 3x plus 7 for angle 1, and 7x minus 13 for angle 2. For angle 3, we have 2y plus 4, And for angle 4, we have 5y minus 23. So let's start with our first equations here for angles 1 and 2. Let's subtract 3x from both sides and add 13 to both sides. So doing that, we get 20 is equal to 4x. Dividing both sides by 4, we get 5 equals x. And then over for 3 and 4, let's subtract the 2y and add the 23. So we get 27 is equal to 3y. Divide both sides by 3. 9 equals y. Moving on. We have a group of friends, they set up a kickball field with bases that are 60 feet apart. They want to verify that the field is a square. So we are told if we have 4 bases for their kickball field, we know that they're 60 feet apart. So one way for it to be a square would be if they measure all of the angles and that's 90 degrees. But that's a little bit more complicated. Another way that they can verify that it's a square is if they can verify that the diagonals are congruent. So since we know all sides are congruent, it's a rhombus. If the diagonals are congruent, it's a rectangle. So, if they are congruent, it is a square. Our last problem for 6.6, we have MNPQ, and we want to decide if it is a rhombus or not. So go ahead, pause the video. I want you to give this one a try on your own, and then I will go through it with you. All right. So if we want MNPQ to be a rhombus, one thing that we can look for is if the diagonals are perpendicular. So if the diagonals are perpendicular, that would mean that MRQ has to be 90 degrees. So I'm going to write that down here. So the measure of angle MRQ would be equal to 90 degrees. If we look, we have this triangle right here, MQR, or MRQ, whichever. The triangle sum theorem tells us that 180 is equal to 32 plus 58 plus the measure of angle MRQ. If we work through this, we will end up getting 180 is equal to 90 plus the measure of there we go, plus the measure of angle MRQ. So 90 is equal to the measure of angle MRQ. So the diagonals are perpendicular. So MNPQ is a rhombus. All right, so last we have our summary of the concepts. So if you don't have this in your notes, I would highly recommend copying this down. It has everything that we need to know about the diagonals of our special parallelograms. So once you're done with this, you are done with topic 6. Congratulations, you made it. And you can go ahead, start that Pearson homework, and let your teacher know if you have questions.